We've been making a lot of triangles that look like this, right? And these are times you just have conversation of what you notice. Can you make me a different type of triangle? Like I can say that I think this is an isosceles triangle with all three acute angles. Can you make me a different type of triangle than this? And you and M can even work together if you want to. So different, look at how L's starting to think. And that's the best part. There's not one right answer, but L's thinking and manipulating and creating, and they're doing it together. And all that. And giggling. So thinking about creating something different than this isosceles acute triangle right here. Do you need tape from us? Geometry is much more than identifying shapes and vocabulary. It's really about spatial sense. This idea that to look at a shape and then have intuitions about it, and also about relationships among shapes, and also geometric reasoning. Be able to look at geometric representations and to reason about what makes it what it is. So as they're building and creating, that's how it comes about, right? And these vocabulary definitions should be co-created with your students. And it's the best way possible as you're doing this. For example, I had asked Elle earlier, my master builder number 2, okay, we have right here an isosceles triangle, isosceles acute triangle where all our angles were acute, and that these two sides were the same, right? Can you create a different type of triangle? And then Elle created this. So some great things to do is, okay, Ellie created something different. So what I might say right here, okay, lift up so we can see it. Okay, will you tell me what you notice about your triangle right here?
I noticed that all the sides are different and that this is...
So you're noticing, I want to touch, so you're saying this side and this side and this side, I have different lengths. Okay, so I'll start to notice something. So I'll notice that all three sides are different lengths. And then this is a time that Elle may not know the name, and we attach the name. And we have a handout, a web link to help you identify different names, because we don't need to have it all memorized as a parent. This is when all three sides have different lanes, it's called a scaling. What else? Yeah. It's like, I think of it like scales on an animal. The scales look different. What else do you notice?
That this one is an acute and this one's an obtuse.
Okay, so you have an acute angle, an obtuse angle, how about
and this
here?
one's acute.
Okay, so then we can even start creating some hypotheses here. And this is where it's good to have a child that's in 3rd grade and a child that's in middle school here. So Elle had noticed that on this triangle, this was an obtuse angle and this was 2 acute angles. So for shapes, so we would call this an obtuse triangle. Is it possible for an obtuse triangle to have 2 obtuse angles?
No, because it has to be larger than 90, and all the angles on a triangle combined is 180. So if you have 2 larger than 90, it'll be larger than 180.
Okay, so you can kind of have questions around like starting to develop characteristics of what makes an obtuse triangle what it is, right? So some things I love to do is this idea of select a shape and tell me what you notice and what you wonder. It might be having 3 geometric representations like the 3 we have right here. Okay, so we can have each of us lift one so you can see them. And I might ask you, what is similar about all 3 of these geometric representations? Can you tell me one thing that's the same about all 3 of these geometric representations?
They're all triangles.
What do you mean by that?
Like this one's a triangle, this one's a triangle, this one's made up of triangles.
Okay. Can you tell me something different